Okay, so one thing to note is that when you've got if you're trying to make a decision about a region like this, where you're doing one bit, what you're not doing is just seeing if this is darker than this, because we don't know for sure. This could be light, it has to be lighter than this, or they have to be near the same, or, you know. So actually, what we are saying is that this minus this is below or greater than some threshold, right? And that threshold also has to be learned. But the idea of this algorithm is that you let through almost everything. You just get rid of the really obvious no's. And then as you go through the features, you get rid of more and more no's. Do you see what I mean? So what you don't want to do, if you set this as a really strict threshold, then what will happen is you get rid of half the faces by mistake, right? So what you do is you set the threshold to let through all the faces of your training set. And yeah, you'll get some other stuff in there, but they'll be dealt with by the later classifiers, right? So it's a kind of, they call it a cascade of weak classifiers. Each classifier on its own, not very good. But when you chain them all together, the entire output is actually quite powerful and can actually find faces really, really quickly. So I'll show you it working. So if I get my laptop, right, hang on. So unplug it. Right, so you can have a go. You can have a go with this because it's coded up in OpenCV, which is Intel's big machine vision library. You'll need to supply your own laptop and camera.
This idea of a cascade of weak classifiers, is that used anywhere else?
So a decision tree is a similar kind of process. A decision tree, which maybe is for a different video, tries to split your data on some feature into two, and then it does it again and again, right? Roughly two. But it's a binary tree. But all of the leaf nodes in the decision tree do something, right? As opposed to this, where most of the leaf nodes are fail. Right, there's only one pass and it's right at the end. Right, so, but it means that, so I think they calculated in the paper that for most bits of image, you maybe do 10 features before it rejects it, right? Which out of 6,000 is not very many. All right, so I've got this machine vision camera here. A machine vision camera is just like a normal camera, except you perhaps have slightly more control over what you do, right? So if I pointed at you, yeah, there you go, there we are. It's pretty good. It's finding the glow on your head, which is quite unfortunate, but if you look at there we go. This is running in pretty much real time. It's worth noting that it won't work if I sort of put, you know, that doesn't work at all, right? Because it's not that advanced. It's a very quick, very efficient classifier, but it's not super tolerant to things like occlusion. So it work on me as well, I think. I've got a very strong backlight here, so let's turn around. How about that? Can you see the screen? I can't see the screen. Yeah, did that work?
Yeah.
But if I put my hand over it, it won't work. The training set you would use for something like this is going to be lots and lots of faces, lots and lots of not faces. Not anywhere near the size or power of a deep network, but much more efficient, runs on an even low-level mobile phone without much effort. And so it still sees a lot of use, right? And it's nice in some ways that something's still going so strong.
This, for instance, is taking 4K pictures, 25 of them every second, and it's still tracking your face.
Yeah.
Do you think it's been refined and is perhaps, working on what it knew from the last frame?
No, but I think what it's probably doing is downsampling the image quite a lot, because the actual region of interest that this thing deals with is 24 pixels by 24 pixels, plus or minus some scale. And so what you can do is you downsample the image quite easily. You don't need 5 to 10 megapixels to be able to perform this technique. And then you'll scan very broadly over the image, saying nope, to a huge amount of the image, and then go, oh, that could be something. Let's keep going on the classifier on that bit, and do it that way. So it's pretty tolerant to different sizes of face, not unbelievably so, but pretty good.